have, whether we're using something for web or we're going to print something, and the colors that we're trying to use in association with those, okay? The more we get into this, Photoshop displays and prints images using specific color modes. So what is a mode? Somebody tell me the definition of a mode.
It's the amount of color data that can be stored in a given file format.
The amount of color data, okay? So when we get in here, I'm going to show you, why do you think color modes are really, really important based upon that statement? The amount of color data that can be stored in a given file format. Why do you think that that mode is really, really important? Why?
Because different modes could hold more data, right?
They could. And more data would typically, in this particular case, since we're talking about color, mean more what?
Organizing pixels.
More color. More color choices. Because on the color hues, or the intensity, or the brightness or lightness of those colors, which would be what HSV is, hue, saturation, and brightness. The hue would be something like, say, red. The saturation would be actually how deep a red that is. How much red do you have in there? Okay? And then the brightness is going to be on the other end of the spectrum, whether it's light or dark. Okay?
Because you could have like a lot of red in there, but you can make it really, really light. Just like,
Kind of like
you can have a bunch of different colors, but you use
You
them.
can change those three things, the hue, the brightness, or the saturation, right? In that particular case. So the way we're going to look at that, in HSB or RGB, how many channels would you be considering that? Let's just take what we're going to use 99% of the time, RGB. RGB, how many channels do you have?
I don't really remember.
3. Okay, and when we get in there, you're going to see where you can actually have either 8-bit, 16, or 32-bit. Yes.
What's the channel?
Red, green, and blue in this particular case.
Okay, so if it was the CY,
CMYK, right?
yeah, that would be, there'd be 4 channels.
Yeah, but actually hang on to that because we're going to talk about that. Because we're very rarely are we going to deal with CMYK on our computer, and there's a reason why. Okay? Why, John?
Is it CMYK only, don't you only have to do it that when printing?
Very good. CMYK deals with items that we're going to send to print. And that's because most print systems nowadays are using a 4-color process. What are those 4 colors?
Cyan.
Cyan, magenta, yellow, and black. That's your 4-color
Why
print
those
process.
4 colors, though?
Because that's the colors that they have to mix to produce all the colors. We're going to talk about it. Just like let's move on and you'll see what I'm talking about, okay? Color model determines how the pigments combine to produce the resulting colors, which is exactly what we're talking about. Back in the old days, when you were learning about colors and painting in class, you learned about
Color.
this, right?
Primary, right?
The primary colors.
Red, blue, and green, right?
Well,
You had red.
I thought it was red, blue, and yellow.
Exactly.
That's
We don't
exactly
have
what I
yellow,
thought.
do we? And yellow, those were your primary colors, weren't they?
Yeah.
And you mixed all these colors, red and yellow gave you what?
Orange.
Gave you orange. Red, blue gave you
Violet.
violet. Yellow and blue
Green.
gave you.
So why do they use the CMYK? Why
That's what we're getting ready to talk about, okay? But what I want you to understand is that model is what creates or what determines how those pigments produce the resulting colors. Okay? So I really need you to understand this concept because each one of those models or those modes is actually going to determine how that works. RGB, which was the red, green, and blue, is used for what you see on your monitor. Because the way that we actually produce color on a monitor is by shining light through phosphorus filters, okay? And so the amount of light that we shine through those phosphorus filters will actually determine what shades of those three colors and the mixture of those to produce the whole spectrum or gamut of colors. Does that make sense? So when we're using light to emit color, we're going to use what three colors?
Red, blue, and green.
Red, green, blue. Red, blue, green. Okay? RBG. Red, blue, green. Okay? And that's how many channels to do that?
Put it on
3.
yellow.
It's important. I'll come back to that, okay? It's a little different than what you studied at a young
So we don't
age,
use
right?
Yellow, we just use green.
Red, green, and blue with light. Okay? Now, when we talk about what you were mentioning was in the CMYK, it's a different process. We're not using light. We're actually mixing colors in a different way in a print process. So the way we establish those colors is actually determined in a totally different way. Because you're not putting light on paper, are you?
You're putting color.
Yeah, you're mixing color. So now what do we have in there? We have that yellow, right? So we have cyan, which is
Like it's a blue.
blue.
It's really
Magenta
like,
is a,
it's like a purple-ish.
or red. It's a red hue, right?
Yeah.
It looks kind of pinkish almost, right? And then you have
Yellow.
yellow.
And black.
What three colors are those?
Those are
Say
Red,
red,
red, blue,
yellow, and blue.
But
The
they're
first three that we just talked about, right?
They're like
That you learned a
slightly
long time ago when we used to
different.
mix colors, right?
Yeah.
And then the black also. So that's that 4-color process that we use to put things on paper, just like when you used to mix your paints. You mixed a little bit of each one of those and you got a lot of different shades, or you could depending upon how much yellow and how much blue or how much red and how much yellow, right? I could either have a real dark orange or a real light orange depending on how I was going to mix those, right?
And you mess up and make brown, and you just get a big frown face.
Okay. All right, so hold on to that, okay? But when we look at an image on our computer, what kind of image are we looking at?
It's a bitmap.
The bitmap. And we know this because you guys have already been working with images, and when you zoom in on those images, what happens to them?
You start to see pixels.
You see all the little dots and pixels, right? So when we talk about those dots, those are called
pixels.
pixels. And each one represents
Color or shade.
color or a shade of that color, right? So lots of different variations of that. So what's going to determine the amount of detail that we have?
Resolution.
Resolution. Resolution means I have more
Pixels.
pixels. More pixels means I have more
Detail.
Yeah.
more detail. It also means I have more what?
Work to do.
Or,
Oh, it's true.
Ink.
like,
Huh?
it's
More
more
color.
Of a, it's more of a like like when
Color's
color
going to depend on the
changes-
mode, whether it's 8-bit, 16. I'll talk about that in a second.
when a color changes, it's not so sudden.
The higher resolution,
It's like
the bigger the
Picture.
file.
oh okay.
The more detailed, the more data, right? Okay, the more colors, the more data, right? So I want you to see those two, both of those going hand in hand together. More colors, more data. The more detail, more data. The higher resolution, more data.
So
that means the more I have of all of those, the larger the file is going to be, right?
Mm-hmm.
That's an extremely important topic for you guys in game design to understand, because what's one of the things that comes at a premium when we're designing games or images or materials or textures or anything else to put in our game?
You only put a certain amount of data on like one disk.
Our games are very resource intensive, aren't they? So the more detail we have in images, the more color we have, the larger those files are, the more resources we have to drive or run that game, right? So you have to know that. You have to learn this concept early on, okay? Because they are very resource intensive, okay?
So if we save an image as a JPEG, are we still viewing it as a bitmap?